So this is 1.9, even though it says 1.6, it's 1.9. Inverse functions. So we can read all of this if we want, but it really is like not in English. To find the inverse of a function, all we do is switch the x and y's. Yeah.
Excuse me. I don't think your screen share.
Thank you.
Thank you.
We just need to switch the x's and y's. So our domain of f would become the range of the inverse of f. Our range of f would become the domain. So when we switch our x's and y's, our domain and range flip as well. We write the inverse as f negative 1 of x. So this is how we write the inverse. Going to the next page. To find the inverse, we switch the x and y's.
Oh, the x's and y's. Okay.
To test to see if two things are inverses of each other, we would just do f of g of x like we did yesterday, and we do g of f of x. If they're equal, then they are inverses of each other. So if we end up getting the same thing, then our two functions are inverses. So for example 3, show that the functions are inverse functions of each other. So first thing we need to do is find f of g of x. So we take our g of x and plug it into the x in our f of x. So our f of g of x would be 2 times the cubed root of x plus 1 over 2 cubed minus 1. So we just took our g of x and plugged it into our f of x function. And now we simplify. So if we have the cubed root of something and we're cubing that, these cancel each other out. So we just have 2 times x plus 1 over 2 minus 1. If we have 2 times something that's being divided by 2, these cancel out, so then we just have x plus 1 minus 1. X plus 1 minus 1 simplifies to x. So f of g of x is just x. Now to find g of f of x, we take our f of x and plug it into our x in our g of x. So this would be the cubed root. In our x, we plug in f of x, so 2x cubed minus 1 plus 1 over 2. We can simplify this. Our 1's cancel each other out. Negative 1 plus 1 is 0, so 2x cubed over 2. Our 2's cancel each other out, so then we're just left with the cubed root of x cubed. And then the cubed root and the cubed cancel each other out. So then we're just left with x. When we get that f of x, f of g of x and g of f of x are equal, then these two functions are inverses of each other. So because this is the same thing, we got the same exact thing, then these are inverses. So we could say f of x. We just have to verify, so we could just say that they're inverses of each other.
Ms. Carver, for the f of g of x, why didn't you distribute the 2 to the 1? Oh wait, no, never mind.
Okay.
Yeah.
So any questions here?
Okay, so inverse just means like equal. Why do they give it the like? That's weird. Okay.
So
I was just wondering.
for these two questions, all we're doing is verifying if they are inverses of each other. So it's giving us two functions, and we just have to verify. On the next page, it'll have other questions where we have to find the inverse. But for these, we're just verifying. So in order to verify, we just need to show that f of g of x is equal to g of f of x.
Oh, okay. Yeah, because I was like on the homework yesterday. Okay. Because I thought it was like how f of like fog and like and like off, like I thought they were like equal to each other, like.
All right, so this next one, again, we're verifying the inverse, but it's asking us which of the functions is the inverse function of f of x is equal to 5 over x minus 2. Here we can do what we did in the last one where we find f of g of x and see if that's equal to g of f of x. But we would have to do the same thing for f of h of x and see if that's equal to h of f of x. So we would have to do all of these. But we can just take the inverse of our f of x and see if it matches g of x or h of x. So when taking the inverse of something, we cancel out our f of x and just change it to a y. So this becomes y is equal to 5 over x minus 2. Because f of x is the same thing as saying y, it's just a fancier way of putting it. So we just changed our f of x, made it a y. And now to find the inverse, we change our y to become an x, and we change our x to become a y. So this will be x is equal to 5 over y minus 2. And now we solve this to be y equals. So what should we do to solve this equation for y?
Do you have to get the numbers on the other side?
Right, so how do we get, what should we get to the other side and how do we get it there?
Times by positive 2, right? I don't know. Times by negative 2.
So we want to get this,
Negative 2 on the other side, right?
we want to get this y minus 2 out from the bottom of our denominator. So we can multiply both sides of our equation by y minus 2. Because this will get it to cancel out with our denominator.
And then x just equals 5.
So here we have x times y minus 2 is equal to 5. So I just multiplied both sides by that y minus 2 to get it out of our denominator. Since it was dividing the 5, I had to do the inverse of division, which is multiplication. So I multiplied it to both sides.
And then it's just y equals 7, or no? Because you plus in 2, you plus 2, or you have to do something with the x.
How do we get our, we want our y all by itself. Our goal is to be y equals. So how do we get our x to the other side?
You divide it.
Divide it.
Yes.
So we divide both sides by x. So now we have y minus 2 is equal to 5 over x. Now how do we get that 2 to the other side, or that minus 2?
Plus.
We add
Add
2. So our 2's cancel out, and we're left with y is equal to 5 over x plus 2. Does this match our g of x or our h of x?
H of x.
H of x. So h of x is the inverse for our f of x.
Ms. Carver,
Yes.
why did you divide the x instead of distributing it?
Because our goal was to get it to the other side of the equation, so we could have distributed, but then we would have two x's. We would have y times x and like a 2 times x, so y times x minus 2 times x, and then it would be harder to get it to the other side of our equation. We could just divide it and get it to the other side, because our goal is to get y all by itself, so there's no point in distributing it because we can just move it.
Okay.
Ms. Carver, why did you switch the y and the x again?
So switch the y and the x is how we find our inverse. So just like on the first. Any other questions here? All right, next page. So here we can see the graph of an inverse mirrors over this line, y is equal to x. So if we had a point a comma b, our inverse would be b comma a. So the only thing that changes is our x's and y's switch. So that's just graphing an inverse. But let's go to the bottom for the examples for find the inverse. So the first thing we need to do is change our f of x to make it a y. And then we flip our x's and y's. So I'm going to change this y to become an x and change this x to be a y. So I have x is equal to 5 minus 3y over 2. And now I need to solve for y. So what can I do to solve for y here?
Multiply 2 on both sides.
Multiply 2 on both sides. So the 2's cancel out, and I have 2x is equal to 5 minus 3y. What can I do next?
Now you add the 5 on the other side. Or I mean you subtract.
Subtract the 5. Yep. So we have 2x minus 5 is equal to negative 3y. And then what do I do?
Now you divide the negative 3.
So I get y is equal to 2x minus 5 over negative 3. Now in the beginning, since I changed our f of x to be y, I want to change it back to be f of x. But this is not f of x, this is now the inverse of f of x. So I'm just going to write it as f negative 1 of x. Because this little negative 1 tells us that it is the inverse. So I just need to change our y back to be f negative 1 of x, just to show us that we found the inverse. Right.
Like it's not like
So this was f of x, what we started
Yeah.
with, and now we found the inverse of f of x.
Yeah, so we only use that when we're just finding the inverse of what they're giving us, right? Not when we're not comparing it to a g of x or anything.
Right. Yeah. So I'm just saying that 2x minus 5 over negative 3 is the inverse of our f of x. Ready for number 2?
Yeah.
Okay, what's the first thing I need to do?
Y equals 3x plus 4 over 5.
Right, so we change our f of x to be y. And then what do I do?
And now you switch it with the x.
Switch it with the x. So I'm changing y to be x and x to be y. Now I need to solve for y. So how do I get y all by itself?
You multiply by 5 on both sides.
Multiply by 5 on both sides, so I get 5x is equal to 3y plus 4. Now what can I do?
Now you can subtract 4 from both sides.
So 5x minus 4 is equal to 3y. Now what?
Now you divide 3.
Perfect. So I have y is equal to 5x minus 4 over 3. What's the last thing that I have to do?
Now you take out the y and put f of negative 1x.
Perfect. F negative 1 of x. So our inverse is 5 times x minus 4 divided by 3. Any questions here?
Nope.
All right, let's look at 3. What's the first thing we need to do here?
You make it y.
Change it to y. Now what do we do?
Now you switch.
Switch them. So we have x is equal to the square root of 2y minus 3. Now how do we solve for y here? What do we need to do?
You square both sides to get rid of the square root.
Perfect. We need to get rid of that square root, so we just square both sides. So the squared cancels out with our square root. We have x squared is equal to 2y minus 3. Now what do we do?
You add 3 to both sides.
So x squared plus 3 is equal to 2y. Now what?
Now you divide by 2.
Perfect. X squared plus 3 over 2 is equal to y. Okay, somebody besides Leonardo, what do we do last?
We change the y to f negative 1 of x.
Yes, but here we started with g of x, so we just change it to g negative 1 of x. Any questions?